All right, you gate industry guys, I just thought this would be a perfect time to show you why you need low impedance on your multimeter. I had a technician call me up, said, hey, I got a bad control board, a bad motor, a bad capacitor, a bad rectifier. Something's going on because I have halfway decent voltage incoming coming from the utility service over to my gate operator, and I know I've got halfway decent power, at least enough power to power a 24 volt molder, so I know that I've got good power. And why isn't my actual motor working? I think I need to change the control board. Well, let's talk about low impedance and why you need a low impedance mode on your multimeter. So most meters will have a 10 meg ohm resistance in between your probes coming into the meter and the CPU that's built into the multimeter. And that is because you don't want to send 120 volts to the incoming power, or in this case, up to 600 volts for this meter, into your CPU, because it's just going to blow it up. So there's a little resistor that's in between the incoming inputs from your outlet and between the CPU. However, depending upon the circuit that you're testing, it can actually trick your meter. And in this case, we're talking about ghost voltage or capacitance voltage. What that is when you have a circuit that is incoming and it's de-energized, meaning there's no power to it, next to a circuit that actually is powered. When you have two conductors that are close to each other, the magnetic fields can create a capacitor. In essence, it always does. Anytime that there's two circuits that are close to each other, that they're next to each other and then they're both energized, they create a capacitance voltage. Well, if you're testing that de-energized line on a multimeter that has a 10 meg ohm load or 10 meg ohm resistance, and 99% of them will have that, in addition to possibly a low impedance mode, it can actually trick the multimeter out. So what I have here is basically just same outlets that you would have on a gate operator coming from your wall, just with an on-off switch. So in this case, it's on. So what would we expect to see if we're getting voltage from the utility to an outlet on our gate operator? 120 volts, right? So when we turn this circuit off, what would we expect to get? 0 volts, right? So let's go ahead and switch the circuit off. Oh, goodness. And as soon as you have a young player that sees that doesn't know what's going on, you could possibly start going down the path of, I have a bad circuit coming from my utility provider that's broken, or in this case, if it was broken, it would show 0 volts, but it has high resistance or it's shorting to something, causing this funky reading. The breaker's not tripping. Well, I can't figure out why this is going on. Well, what it is just the CPU thinking that there's actually voltage there when there's not. Now, I'm doing it a little bit different with the capacitance voltage because I'm using actually this light switch to create a little bit of a power draw on there and creating that ghost voltage, if you will. But some multimeters actually have a low impedance mode. So now what would we expect to see if we put it in low impedance mode? And by the way, don't do what I just did, sweep the dial with your leads in the circuit. I'm doing that because I know I have good input protection on this, but anytime that you're sweeping the dial, you need to take your probes out of the circuit. So now will we see the same exact voltage, which was 64 volts, when we turn it from a 10 meg ohm input to a 1000 ohm input? No voltage. Well, hold on. Maybe the whole circuit's bad, and that gives you a little bit of a clue. Maybe the whole circuit's bad. I still got my 123 volts. Well, what is happening is this light is actually causing a little bit of bleed because it needs to be turned on, or not need to be, but that's how it's designed, is turned on. When the circuit is off, it's energized so you can actually see it when a dark room, okay? So it's actually creating a little bit of electricity in there, and it's freaking out the meter when it has that 10 meg input. So this is a trap for you young players out there. You need to have a meter that has low impedance. This is one of my favorite go-to meters, but that has low impedance, because it's going to save your technician from going to the first junction box to the next junction box to the next junction box to the next junction box, going around trying to find that 120 volts when all it is that there's a circuit that has a little bit of a load on it, or it's actually capacitance voltage where an energized circuit's next to a de-energized one. So low impedance, think about having that on your multimeter. It can save you hundreds of dollars in diagnostic, and it's a very, very common issue, especially in new construction where you have certain parts of the building energized and certain parts of the building not energized, but the wires all going through the same conduit. It can trip you up.